Use the quotient rule to derive the derivative of tangent of x. All right, well, first things first, what is tangent of x? Tangent of x is the same as sine x over cos x, right? So I'm going to need the quotient rule for this. So if I label u and I label v, the quotient rule would be the d dx of u over v is u prime v minus v prime u all over v squared. In other words, the derivative of the top times the bottom minus the derivative of the bottom minus times the top all over v squared. So let's see what happens. So let's take the d dx of sine x over cos x. All right, let's do that. Just writing it out. Okay, so that's going to be u prime v. Let's actually go over here and find out what u prime, v prime, and v squared is. U prime is going to be the derivative of sine, which is cos. Okay, very simple. And v prime is going to be the derivative of cos, which is negative sine, also very simple. And then v squared is going to be cosine squared, so we'll say cos squared. Now that we have that, let's plug it all in. U prime is cos x, so cos x times v, which is cos x again, so cos squared, minus v prime, which is negative sine x, so there's a double negative right there, very interesting, times u, which is sine x, all over v squared, which is cos squared x. Okay, cosine times cosine is cos squared x, minus a negative, so plus sine x times sine x is sine squared x. And that's all going to be over cosine squared x. Now, I know what you're thinking. Oh, a cos and a cos, they cancel out. No. This is actually what happens. There's a Pythagorean theorem identity that says cos squared x plus sine squared x equals 1. That comes from the unit circle back in pre-calculus, boys and girls. So this whole numerator turns into 1. And that's all over cos squared x. Well, we know also from pre-calculus and geometry and all that good stuff that 1 over regular cosine is secant. So 1 over cos squared is secant squared x. So after all of that, the derivative of tangent x is secant squared x. And we did that using the quotient rule. Isn't that neat?